This is Greg Trautwein with Marine Technology TV, and we're very pleased to be joined today by Judson, Kauffman, and Joe Wolfel, the co-founders and the co-CEOs of Terradepth, to discuss recent advances for Terradepth's unmanned submersible. Gentlemen, to start, thank you much for joining us. I'm sure that many of our viewers know the Terradepth name, but to start, can you give an overview, a by the numbers look at the company today?
Sure. Yeah, thanks for having us on, Greg. Joe and I got into this industry as total outsiders, aside from our Navy experience, which did not include very much undersea technology. Joe and I were in during the height of the war in Iraq and Afghanistan, which is where we spent most of our time. So we really did not know much at all about the ocean data world, or really the maritime industry at large. But we were working in technology as consultants, and we have been watching the boom with respect to space exploration and the advancements of various space technologies, which is fantastic. It's exciting, but it just seemed like somebody should be doing the same thing for the ocean. Our basic understanding of kind of ocean tech, generally speaking, was that it was a little bit behind, at least what we saw some of the tech, the space tech companies posturing themselves as. So we looked at it for several months and decided, hey, this is exciting. This is cool. There's an opportunity here to bring some pretty modern technology into this somewhat aging industry and kind of make it new. So we stepped in full force.
That we did. Yeah, so as far as where we are, we'll get into it a little bit in more detail here with you, Greg. But company is just wrapping up our prototypes on both the data collection side and the data interface side of the house. We've got 12 amazing full-time team members, some folks that we contract with as well, and they're punching way above their weight as far as productivity. So proud of everything that everybody's done here.
Can you briefly discuss the mission of the company you started, with insights on how your unmanned solutions differ from others in the field?
Sure. So the vision of the company is really to create a complete, accurate, and immersive virtual ocean experience, really to connect humanity with what's the actual last frontier on Earth, right? And so you're taking that vision into account. The mission then becomes, well, how do you drastically scale ocean data collection while simultaneously radically improving the user data experience with that now scaled data? So that's the mission. Twofold there: data collection, data interface, and how we differ. We really differ in two major ways across those two lines. So when you look at what it takes to drastically scale ocean data collection, specifically high resolution deep ocean data collection, you need to remove, or at the very least minimize, the human from the data collection loop. And so the way that our data collection platform differs from anything else that's out there is we have a single variant dual purpose solution. So we make one type of robot that's capable of existing at the surface and replicating what is a currently manned surface vessel. And we've got the exact same robot, its twin, underwater, doing a deep ocean, high resolution, high energy data collection mission. And when we run low on energy submerged, because we're on battery power, we simply switch places on the water column, and then we continue on mission. So simple solution that we think improves reliability, improves resilience, therefore improving endurance and drastically reducing the cost of that operation. And then on the user interface side of the house, we're taking a lot of the acoustic data that's coming off the robot, we're transforming it into a point cloud, and we're making it available for user interaction on a cloud platform.
Okay, well, getting information more efficiently and more cheaply from the ocean environment, it's a good goal to have these days. We understand that you recently completed a phase 1 trial in Lake Travis in Texas. Can you give us a brief on the focus of the trials and the results?
Sure. The focus really was just to prove to ourselves and to our stakeholders that the robot that we built, it was supposed to be fully autonomous, actually could operate fully autonomously and end to end. So could the robot go into the water, see something and then make a decision based on what it sees about what it should do next, without having to contact a human and say, hey, here's a picture of something. I don't know what it is, but standing by for further, further mission tasking. We wanted the robot, we programmed it, we built it to be able to give itself that level of direction, right? So in situ data processing and at the edge decision making. So that's really what we proved. And the next step for us is to prove the ability for that same robot to recharge its own batteries while it's deployed at sea. So as soon as we wrapped up the first trials a few weeks ago, we got to work on this next milestone. So this summer, we look to integrate that energy recharge.
Okay. Just as a side, what's the key to the energy recharge?
Yeah, so we have a patent for hydrogen fuel cell system. We're using right now in the prototype, we're using heavy fuel. So basically a kind of a standard diesel electric system. So we have lithium ion batteries on board. In the future, we hope to integrate the alternative fuel system, but right now we're going with this heavy fuel. So the way that it works is while it's submerged, it's using the batteries for power. And once those batteries run low, the system recognizes that, and then it can come to the surface. And when it gets to the surface, now it can breathe air. And when it can breathe air, it can turn on the generator. And that generator then charges those batteries back up. Once they're fully charged, it dives back down to continue its mission.
As I said before, seamlessly gathering, delivering, processing information from the oceans to help form actionable intelligence is an ongoing quest for many. From where you sit, what do you see as the primary hurdles to achieving this mission?
Yeah. So if you're talking about bathymetry or understanding side scan sonar or synthetic aperture sonar data, I'm sure most of your readers and followers are very familiar with the signal attenuation problem that exists in the ocean, right? And so, the reason that we don't have high resolution bathymetric maps of the entire ocean is because we can't fly all the satellite constellations that we have over the ocean and have that energy penetrate to the water column to get that accurate image. So that means you've got an in situ, an on-premise data collection requirement, which means you have to be in the water, which means you have to be underwater. And once you start going underwater, if you're going to remove the human from the loop, now you've got very sophisticated sensor packages that need to be powered. Those sensor packages are extremely expensive right now, especially considering they have to go in a lot of cases, their own pressure vessels. So now you've got a pressure vessel cost. So anyway, a long way of saying that it's just really expensive to send stuff underwater and then have it hopefully come back on its own, right? So that's one major driver. The other hurdle that I think I'll articulate here, and just in the interest of brevity, would be just lack of data interoperability in general, right? So file formats are all over the place. They don't work well together. The existing ocean databases aren't feasible in a lot of cases. So you've got a lot of ocean data that's out there that, while it's all still sparse, because again, you go back to the cost of collection, it's, there's not a whole lot of ocean data out there that's really usable. Even if it's usable though, it's not searchable because you haven't aggregated it all in one place and your search functions don't work on those differing file formats. So I think those are probably the two major hurdles I'd highlight.
When you look at the markets and the end users that you see as having the greatest potential to benefit from the Terradepth solution, which are they?
Yeah, so all of those industries you mentioned, all the conventional industries who are spending money today on, maritime data, subsea data, they'll benefit obviously because we're trying to scale that data. So they'll have access to more data. It'll be less expensive. And I think more importantly, the risk to human beings who normally would be out there collecting that data on ships, et cetera, will be reduced because we've pretty much removed the human completely from the loop. So that's point one. But I think who will benefit the most are those stakeholders or those markets, those industries who currently can't afford to pay the rates of what it costs to purchase this kind of data. We want to scale it to such a degree that we democratize that data And so now anybody who cares to look at what the weather is going to be in the next few days will benefit from the same data, right? Because what causes changes in the weather? Well, that's the behavior of the planet. And the vast majority of the Earth's biosphere is underwater. And a main contributor to the inaccuracy of weather reports is that the meteorologists are using only a small fraction of the available data, because it's just too elusive to go underwater and collect data on scale right now. It's far too expensive. So we're using terrestrial sensors to try to, paint a picture that of a place that largely isn't a terrestrial place. So you think about, those weather apps, you think about surfers looking for, new waves, fishermen, insurance companies who are protecting, assets at sea, or even protecting homes along the coast that want that data. There's a very, very long list. One that I get excited about is the pharmaceutical industry. Most of our medicines in the market today, I think 80% of them are derived from or synthesized by a natural resource. And most of our natural resources, the vast majority of them, are in the ocean. So as we discover more resources, more plants, more members of the animal kingdom, and begin to understand them, we'll be able to grow our depth of knowledge of what types of medicines may be available in this system. So we're excited about that.
I know you have the second phase of testing coming up in the summer, but when you look ahead, what's next for Terradepth?
Yeah. So moving to scale, right? So taking all the lessons learned from all the work that we've done over the last 2 years, taking a look at how these prototypes have panned out, revamping them to make them hardened and resilient so that they can operate in the ocean environment over time. That's one side of the house. And then the other side is drastically increase the amount of data that we have coming into the Terradepth cloud platform, right? So you've got native data sets that we'll be collecting and non-native data sets coming from elsewhere, and really fusing those data sets together to make them actionable and usable for a client base, right? So that's the near future.